Welcome back to Everything NCEA for another Maths Monday. Today we are continuing with our differentiation level 3 journey into lesson 2. So in lesson 1 we covered the power function and, that's not what I wanted. We covered the power functions with polynomials, so basic differentiation. And then today we will be doing the chain rule, or otherwise known as composite functions. Now, as you can see with the blue highlight there and the blue highlight here, both these skills are mostly achieved skills. However, with the differentiation paper, exam paper at the end of the year, they do mix achieved and merit skills together quite a lot. So the chain rule, this one's definitely achieved. Power functions and polynomials are definitely achieved. The chain rule, you can have some merit questions. So, what the chain rule, or composite functions, actually is. What it basically means, and I've written it out here, if we get a function that cannot be readily expressed as a sum of terms, like this here, fx equals 2x minus 3 to the square root to the power of 3, we would then express it as a composite function where fx equals the square root of z. All we've done here is we have substituted this value right here for z. That's all we've done. And the way that I like to think about the chain rule is I think about it as more like the substitution rule. You are substituting in another letter, which you would have done in basic algebra. You're substituting another letter for a function to make it easier to understand. And now this can be expressed here. So if the function of x equals yz, which this can be expressed just like this, then the differentiation of fx is a differentiation of y in terms of z multiplied by the differentiation of z in terms of x. That's a lot to understand, especially if this is your first time doing differentiation. So we'll go through a worked example. Still got the rule up the top here. So we get a question like this. hx equals 2x plus 4 to the power of 3. Now, if we try to differentiate this to the right, this here, it's going to be hard because it's all to the power of 3. So to make it easier, we substitute this inside the bracket for a g. So it's gone from 2x plus 4 to the power of 3 to g to the power of 3. So when we do this, it's the same as doing this part of the equation. So the differentiation of f in terms of g. So all we're going to do is differentiate this g here, like we learnt in the last lesson. So multiply it by the power, so 3g, and then the power, and then 3 minus 1. So all we've done is differentiated that 3g, or g to the power of 3. And we can also write that as 3 minus 1 is 2. So the differentiation of f in terms of g is 3g squared. And then we're now going to do this bit, the zx, or gx for this question. Sorry, that. And the only reason the letters have changed is because each question will give you different letters because NCEA suck like that. So we've done the first bit here, now we're going to do the second bit here. So gx equals this, which is that. And if we differentiate that, it's just going to be 2, because that's what we learned in the last lesson. That x is to the power of 1, we multiply it out, 4 turns to 0, 2x turns to 2. If you're stuck on that, I'd advise you to go and watch the previous lesson, because that goes through that quite well. And now, this whole rule here, I'll give it a nice blue. This rule is the exact same as this, just with different letters that the question's given us. So here where you have y, differentiation of y for z times differentiation of z for x, we've got the same thing here with differentiation of f for g and g for x. So we'll pull the figures across. We have the differentiation of fg multiplied by the differentiation of gx. That's all that is. That 2 goes from there. And this is this. Oh, sorry. This is the exact same as this. It's just we know g equals 2x plus 4. And so we got 3g to the power of 2 here. And so 3, substitute in this over here. So 3g to the power of 2. So we've got this function here multiplied by this function equals this. And then you multiply that out. The 2 multiplies by the 3, and we've just got that. Still might be slightly confusing, but that is the basic rules for chain function. You're substituting in something, a letter like g, to make the question easier to differentiate, and then you are multiplying the differentiation of the original function by the differentiation of whatever you've made g. So we'll move on here. Just like the last question, we will make g equal 5x minus 1. So the differentiation of y now equals g to the power of 3, because we've substituted that g in. And so we'll just get rid of that. And we'll just make, that's what y equals. So the differentiation of y equals 3g to the power of 2, because all we've done is differentiate the above equation, which we can also write out as put the 5x minus 1 back instead of the g, resubstitute that back in, and then the differentiation of g equals 5. And then we know that the multiplication of both these functions, so differentiation of y times differentiation of g equals 3 5x minus 1 to the power of 2, which we have got from here. So this is that multiplied by the differentiation of g. So that's also that multiplied by this, which is just 5. So you can see now that it's highlighted that the differentiation of what? The differentiation of this first part, the y in yellow, multiplied by the differentiation of the term you've made g, which is in red, and then you just multiply them together. So 15 5x minus 1 to the power of 2. It's a very simple differentiation chain rule question, and enough to get you achieved. So move on to another achieved question. So first we're going to find out what we're going to make g. G will be the long term inside the square root here. Yep, that's g. And so we can rewrite this as the square root of g, because we've just we've said that g equals this big long term here, and so we can just rewrite that as the square root of g. So our first step is to differentiate the original kx, which would be, we can also write this is the same as g to the 1 over 2. If you don't get how I've got that, I'd watch the previous video, but basically these two equations are the same, this one and this one, because square root is the same as to the power of half. So we'll differentiate this. So times it by the power, and then would do the power minus 1. So 1/2 minus 1 would just simply be negative 1/2. And then resubstitute g in. 1 over 2, 3x squared minus 8x plus 2, or 3x minus 8x, sorry, put squared, plus 2 over 2. And that's both to the power of negative half. There we go. And so we've differentiated this part, the first part, so we're now going to differentiate g. And the differentiation of g, and remember, g is just this here. The differentiation of g is 6x minus 8. Just a bit of nice, easy, simple differentiation there. And so if we remember our previous rules, we've got the differentiation of kx multiplied by the differentiation of, well, that'd actually be the differentiation of kg, because we're differentiating in regards to g, multiplied by the differentiation of g in terms of x equals our answer. So we know the differentiation of kg is this, which is the same as that. So we can write that in. 3x squared minus 8x plus 2 to the power of 1 over half over 2 multiplied by the differentiation of g in terms of x, which we know is this. So multiplied by 6x minus 8 will equal our answer. Now, we come in from our last video that if we have a negative exponent, we can simply move whatever the negative exponent is to the power of to the bottom. And that's how we get rid of our negative exponents. Like that. Again, if that's tricky, I'd go look at the previous video because that explains it better, but we'll just move on for today. Times 6x minus 8, which equals 6x minus 8 over 3x squared minus 8x plus 2 to the power of 1 over half. Or when we simplify, and we're going to simplify by dividing everything on the top by the 2 at the bottom. 3x minus 4 over the square root. And I've got that from this power here, because remember, to the power of half is square root. Is 3x squared minus 8x. Now that was a lot of steps, but again, just an achieved question. You're not going to get anything more than achieved for that one. It's a lot of steps, but the actual differentiation is just simple differentiation. You just need to know what the chain rule is. questions, I'll give you one example of a merit question for the chain rule. It's going to give you something like this. Find dk over dx if k equals that and v equals that. So the first step is you want to get the question, now I'll write in blue, you want to get the question to be k equals something in regard to x. Because here you have dk over dx. So you want to have your question to be k equals something x. Whereas over here we've got k equals 4 over v. We want to get rid of that v basically and make that v an x. Now, how do we do that? Well, we know what x is. No, we know what v is. V is this. So we'll substitute that in. So v is 3 minus x to the power of 1 over 2, or the square root. And v is square rooted as well. So this function here is v. We've just substituted in what v equals, and v equals this here. And then v is also being square rooted. So it's 3 minus x to the power of half to the power of half. Now, if you don't know what that is simply 4 over 3x, no, there's no x there, 3 minus x to the power of 1 over 4, if we look back at our basic exponents knowledge. So now we've got k equals something x, which is what our original question asked for. So we can now turn this to the chain rule. How we'll do that is we will differentiate k in terms of x. Actually, first we will make g equal 3 minus x. That's what g is going to equal. And so k now equals 4g to the negative quarter. And that's really sloppy handwriting. To the negative quarter. And just like the last time, if we're moving the g from the bottom, so the g that would be here, we're moving it to the top, and we would do that by the reverse of what we did in this question. We went from negative to positive by bringing it down. So if we want to go positive to negative, we bring it up. And again, that's just basic year 12, year 11, just maths knowledge. So if that's struggling you up, I'd have a look at some just year 11, year 12 stuff, just to get that skill a little more down. And when we differentiate this, we're going to get negative 4 over 4, because we're multiplying the power by 4g. Negative 4 over 4g to the power of negative 5 over 4, because we're minusing that by 1 when we differentiate, remember? Oh, sorry about that. I've just opened a nice note. So that is the differentiation of k in terms of g. We've done that step. And then again, we can rewrite that a little better. So minus 1. We're just replacing g with what g equals. And negative 4 over 4 is negative 1. So negative 1, 3x to the power of negative 5 over 4 is the first step. And so the second step is to differentiate g in terms of x, which would be simply -1. And again, we know that differentiation of kg multiplied by the differentiation of gx will give you, in this case, dk over dx, your final answer. So we know that differentiation of kg equals this. So we'll put that in. -3 minus x, -5/4. Or, remember, we'll do that step next. It makes more sense. Times, so that's that. Times, we'll make this a nice blue. Differentiation of gx, just here, times -1. Now my first step would be to sort out this exponent, because currently it's a negative exponent. And to make it positive again, we'd move it down to the bottom. So, like that, times -1. And now -1 by -1 is just 1, which gets 1 over 3x to the 5/4. So all we've done with this question is the exact same. We've used the chain rule to get it to this last step, or you could also write it as 3 minus x -5/4, whichever way your teacher wants it. In the exam, both ways will give you the right answer. And in the exam, that would also be a merit, which is nice because it's no different to this. All the skills are exactly the same. It's just this initial step here, this understanding where to get this equation from, is where the merit comes into it. Because when it's asking you dk over dx, you want to get differentiating k in terms of x, whereas the question gives you differentiating k in terms of v. And so you've got to be really careful when you look at that. Now, if there's any chain rule questions you want looking at, feel free to send them through. Put them in the comments, send them through email, whatever you feel like. I'll give you a video back on how to do them. But yeah, that is the chain rule or composite functions. And it's a skill that you're going to use right through differentiation, so it's a really good one to practice. Hope that helped. See you next time.